Hey, should we get, all right, should we get going? Should I give it
Go
another
for
minute?
it.
Go for it.
We
All
can
right.
go for it.
Hello, everyone. Thank you for joining us tonight. My name is Amanda Begley with Tree People, and I'm joined with our partners from Stantec, who will introduce themselves now.
I'm Andrea. I'm from Stantec, and yeah, I'm excited to have this workshop today.
Hello all, my name is Atlee Keller, also with Stantec. Happy to be here.
All right, so as you can see, we are very excited to be with you tonight for our workshop on drinking water quality. Next slide. So let's start with a land acknowledgement. We acknowledge that the lands and waters in the upper Santa Clara River are the unceded ancestral homelands of the Tataviam, Chumash, Serrano, and Tongva people. We gratefully acknowledge the native peoples on whose homelands we live and who are the ancestral stewards of land and water. We make this acknowledgement out of respect for their long-standing connection to and protection of this area's watershed. We recognize that these tribes are still present in the area, along with a large number of displaced Indigenous people. We urge you to learn more about how to engage with tribal communities in your water work and beyond, and to watch the recordings of the Water Talks training, water training allyship with tribal communities, organized by Sacred Places Institute. You can scan this QR code that is on the screen with your phone to view that workshop, and the link can also be found in the chat. Next slide. All right, so tonight's workshop is brought to you by the Water Talks program. So Water Talks is a public program that is designed to generate and increase public involvement in the planning of a sustainable water future for California. The full name of the program is the Disadvantaged Community Involvement Program, but we call it Water Talks. The program has been in place since 2019, working in a tight-knit partnership with Stantec, Council for Watershed Health, and Sacred Places Institute for Indigenous Peoples. The program has three main components. Number one, authentic and often action-based community engagement. Number two, a thorough strengths and needs assessment completed in 2021. And number three, the development of projects and programs identified through the needs assessment. All right. Now, what will we learn tonight? These are the learning objectives. So number one, you will understand the upper Santa Clara River watershed and your water sources, answering the question, where does my water come from? Number two, you will understand how water gets to your tap from the source into your home. And number three, an overview of drinking water quality concerns, contaminants, and regulations. And number four, be able to find, read, and understand your annual water quality report, also known as your consumer confidence report. All right, next slide. All right, now we're gonna start with an icebreaker. If you could put in, oh no, wait, not a chat. What is one way you used water today? If you could go to the link in the chat, that will take you to a place where you can add what is one way you used water today. All right, awesome. All right, so we've got everything from brushing teeth, washing hands, dishes. There's some plants getting some water I'm seeing in the chat, cooking. Use water all the time with cooking. Let's see, trees, the trees need water. Tea, that sounds good. I could use some tea. Let's see what else we got here. Citrus could use some water. All right. The teeth are very washed, we have decided through this activity. All right, so without further ado, I will hand it off to Andrea.
Yeah, okay, so I'll start with the first learning objective. Where does my water come from? You go to the next slide. Okay. So the integrated regional water management is a collaborative effort to identify and implement water management solutions on a regional scale. So this map here shows the region, and shown in green is the Upper Santa Clara River watershed, which is our focus here today. And just to give some context, a watershed is an area of land that drains all of its water to one specific water body. And this can be a reservoir, a mouth of a bay, or any point along a stream. And when talking about the Upper Santa Clara River watershed specifically, this is an area that includes the upper reaches of the Santa Clara River, which is the largest natural river remaining in Southern California. If you go to the next slide. So diving into water systems specifically, there are different categories of water systems, and these are the three main ones shown here. So first, we have public water systems, which are water systems with more than 15 connections that serve more than 25 people at least 60 days of the year. These are regulated by the state. Then we have state small water systems, which have between 5 and 14 connections, and they do not regularly serve drinking water to 25 or more people 60 days out of the year. And they are regulated by local county environmental health departments. And then we have domestic wells, which serve up to 4 connections, and they fall outside federal and state regulation. And because of that, they are not subject to the same type of testing and monitoring requirements as our public water systems and state small water systems. And our focus here today will be, if you click public water systems. However, if you are on a state small water system or a domestic well, let us know. There are workshops that will focus on these types of water systems specifically. In any case, though, we will talk a lot about water quality in general, and that applies to all kinds of water systems. So now we will, if you go back to the same link that's in the chat, we want to ask, what kind of system are you on? And there should be a drop-down menu for you to choose the type of water system you're on if you know it. But if you don't know it, that's also okay. There's an option for you to say, I'm not sure. And if you are on a public water system, we will go through an exercise later in the presentation where you can type in your address, and this tool will show the public water system that your house is at. So it's a way for you to find out who your water provider is if you are on a public water system. So, okay. So yeah, and then we have that second question to see if you know. Again, if you don't know who your water provider is, we will find out later in the presentation. All right. So now I want to talk a little bit about water system governance. This will be more specific to public water systems. There are different ways to classify public water systems, and it can easily get complicated, but there are some helpful tools to learn more about water systems specifically. This map here is a snip of the Water Board's drinking water system outreach tool, and the link will be sent in the chat as well. You can save it and explore it later. It's really cool. But here in the red circle, that's like the area that I was showing the previous map earlier, the Santa Clara, the watershed that we're focusing on. And then pointing towards it is the Santa Clarita Valley Water Agency, which we will talk about more later in the presentation. And just to give an overview of how the tool works, if you know your water provider, you can enter it in the search box. So let's say I'm looking for the Santa Clarita Valley Water Agency. I type in the search box, and this box appears, and it gives me lots of information about the system. But since we're talking about water system governance here, I want to point out specifically the owner type. So here it says it's local government. So that means the local government manages the Santa Clarita Valley Water Agency. So it's a publicly owned public water system. There are other types of water systems. Some are privately owned, and these include investor-owned utilities, mutual water companies, mobile homes, and others. So this will kind of just give you an idea of who who governs my water system. And in this case, it's the local government. So if you go to the next slide. Okay, now let's zoom in even farther. Let's talk about the water sources, first for the region in general. So the Upper Santa Clara River watershed area gets water from 3 major sources: imported water from the State Water Project, local groundwater, and then also recycled water. For the groundwater, the watershed gets, I guess, like the region gets water from 3 different basins: the Antelope Valley Basin, the Acton Groundwater Basin, and the Santa Clara River Valley East Groundwater Basin. And this water is stored underground, and there are pumps that water agencies use to get the water out of the ground. And then the second one is imported water from the State Water Project. So in this map, the one of California, there's like a big arrow that shows the California State Water Project. That's the California Aqueduct, and it essentially brings water from Northern California, from the mountains. So like all the precipitation that's collected there, it goes all the way down to a region, and then we can use it. And then the last one is recycled water. This is becoming a key resource for increasing local water supplies and improving the long-term water resilience. So many water agencies are increasing their use of recycled water, and it's very important to, just increase long-term resilience. If you go to the next slide. So diving into the Santa Clarita Valley Water Agency specifically, the agency receives water from those 3 major sources as well. And they also have water banking programs, which I will get to in a second. But the agency in general, they serve 296,000 people. And similarly to what I mentioned before, the imported water comes from the State Water Project through the California Aqueduct. It journeys hundreds of miles from the Sierra Nevada mountains in Northern California all the way to the region. And then local supplies, they have groundwater as well. And they have a series of wells across the Santa Clarita Valley. And that's how they, if you see the diagram on the right, it's very simple, but it shows like the water being underground, and then there's a pump that brings it out of the ground, and then it's available for use. And their water banking program, so as you can see in the picture on the left, it represented 43% of the supply sources this past year. So it's a pretty significant amount. And during wet years, the Santa Clarita Valley Water Agency captures all the extra water, and they store it. It ends up working similar to groundwater. They store it all in water banks underground. And again, they use wells, pumps to like get it out of the ground. And all of these percentages, the ones shown here, they are representative of this past year, but they vary year to year. They depend on climate conditions and other external factors. So when thinking about the water sources in general, it's important not to give numbers because they vary so much throughout the years, but this is the reflection of the supplies for this past year specifically. If you go to the next slide, I'll pass it back to Adley, who will talk about the path to depth.
Thanks, Andrea. So as we just talked about, your water comes from a variety of sources, whether that's imported, local supplies, surface water, groundwater, it could be recycled water. And the path to tap starts when that source water is conveyed to a treatment plant to remove any harmful, whether that's bacteria, viruses, metals, organic compounds that might be present in the source water. The treatment process itself is determined by where the water is coming from, what the source is, and what the quality of it is entering into the treatment plant. For instance, groundwater would need different treatment than recycled water. From the treatment plant, the distribution system then carries the water to your property through a network of pipes and infrastructure. And then the water goes to the service lines, which cross your property line, connecting the distribution system to your plumbing. And the water enters your home via your premise plumbing, which is the pipes, the fixtures inside your property or inside your home. It includes your faucet where you get your tap water from. And because the water quality can change from that point of distribution to when it's actually coming out of your faucet, today we're going to talk about some of those solutions to potential concerns that arise with premise plumbing. So we'll pause now and open it up to questions if we have any.
So I noticed a comment in the chat about not using more state water. And that goes back to what I was saying, that it varies so much year to year. And actually, so this number that I presented, the 17%, is based on the most recent consumer confidence report, which was released this year, like super recent. I'll go over that more later, but the previous one, so based on the year before, it was 63%. So it changed from 63% to 17%. And what went up was the water banking program that I was explaining earlier. So again, year to year, depending on external factors, climate conditions, the percentages will vary quite a bit.
Looks like Lynn has her hand up. You can unmute yourself. Thank you.
Yeah, I'm familiar with the San Joaquin Valley and all the agriculture there, and I'm really surprised that we're getting a huge amount of water from there. Is that like going to be a big issue in the future? Because they're always talking about how they're not able to grow crops because they don't have water. And yet there's this water bank that we're taking water from. Is that going to be an issue in the future?
I don't think it's gonna be an issue. Actually, like one of the objectives for many water systems is to separate more from the imported water, because that's less reliable than local water. So the goal is to increase local water sources compared to continuing to rely on imported water supplies.
And I'll just add on that in a year like this with so much rain and floods, having banked water and the underground infrastructure to store that water really helps with that resilience.
So you're saying that the banked water in Kern County is part of our water supply as part of our groundwater. You don't think there'll ever be an issue with the farmers in San Joaquin Valley?
So my understanding is Santa Clarita is stashing that water there. They're not taking the water from the community.
Mm-hmm.
So, and then it also happens to be right on the line of the California aqueduct where the water is banked. So they can still use that aqueduct to move the water down. That typically the state water project water comes from the north down to the south. So yeah, it's their way of putting like a savings account somewhere. It just happens to be in Kern County. But yeah, so they just bank water, and like we had so much this year, they were able to, you know, keep it and store it for later.
So is it like a cavern or something, like an underground cavern?
Yeah, it ends up being pretty similar to groundwater. So they like inject the water into the ground, and if you remember, you can, well, it's quite far back, but I don't know if you remember that small diagram that I was referring to, like with the blue lines underground. It ends up being, yeah, like that. So it ends up working like pretty similar to groundwater, and it's called an aquifer. So they store it in the aquifer, and that's like the bank. Okay, so if there are no other questions, I'll go and start talking more about the common contaminants. So first, I'll start giving some context about drinking water regulations. So there are primary drinking water regulations, and these are legally enforceable standards for contaminants that affect health. They include maximum contaminant levels, monitoring and reporting requirements, and water treatment requirements. And then we have secondary drinking water regulations, which are guidelines associated with non-health related considerations like taste, color, and odor. And although they are not enforceable on a national level, they are enforceable here in California. So Okay, so to create these regulations, there are lots of regulations, and it's a very complicated process. So I'm gonna try and explain how they come to be. So there are two parallel trains. So first, let's start with the national level. So there are scientists doing the research about contaminants, learning more about them, and if they find evidence that a contaminant has a negative human health impact and is present in water sources, then they use that evidence and they go through and create a maximum contaminant level goal. And the goal is the ideal level, the point at which for sure, like there are no health consequences. It's like the dream goal. And then based on that, and considering now our technology capabilities and economical capabilities, they develop the maximum contaminant level. And that's the regulation that water systems need to comply with. That's the limit. And parallel to that, California does a similar process. So they develop what is a public health goal, which is similar to the maximum contaminant level goal, the ideal level for a contaminant concentration. And then from that, the California State Water Board sets the maximum contaminant level, the state one. And sometimes these numbers are exactly the same. Other times they vary a little bit. California has maximum contaminant levels for some contaminants that the EPA, the US EPA doesn't have maximum contaminant levels for, so they vary. But water agencies need to comply with both sets of regulations. And then to add another layer to it, there are some contaminants that still don't have maximum contaminant levels, or that they are in process. So like I said, this is a complicated process. It takes time. So when a contaminant doesn't have a maximum contaminant level, California sets some other limits, which are shown here, the notification level and the response level, to provide some sort of guidance as they continue to develop the maximum contaminant levels. So the notification level is just the level at which water systems are required to tell people that X contaminant has been detected. And the response level is the level at which they need to take action. So that's the level at which it's recommended to remove the water source from service. So if you go to the next slide. So now diving into contaminants. So the EPA categorizes them into these 6 types of contaminants. And I'll define them and I'll go over some of them later. I know it's going to be a lot of information and you might not remember, but the point here is to explain and to show that there are many different contaminants and they vary between themselves, and there's a way to classify them. So microorganisms, they are tiny living organisms that can only be seen with a microscope, and they include bacteria and viruses. Then we have disinfectants. These can be chemicals like chlorine, for example, or a physical process like ultraviolet light, and they are used to kill microorganisms. But they also have regulations to make sure that you're adding the right amount to be able to kill those microorganisms. And then we have disinfection byproducts, which are also connected to disinfectants. And I will actually talk more about them later on, but essentially they form when disinfectants react with other stuff that's still in the water. And there are regulations around that because the goal is to be able to add the disinfectant and don't have any byproducts from it, right? The disinfectant is supposed to kill microorganisms, not create something else. So that's why there are regulations around disinfection byproducts too. Then we have inorganic chemicals. These are mineral-based compounds, such as salts and metals, and they can be naturally occurring or result from industrial discharges. We have organic chemicals. They are carbon-based chemicals, and they include solvents and pesticides. And lastly, we have radionuclides, and these are an unstable form of a chemical element that decays and they emit nuclear radiation, and they can be naturally occurring in the Earth's crust, or they can also be produced from mining activities, for example, or oil and gas production. So like I said, just 6 categories in which the EPA classifies the different types of contaminants. And then since we're gonna go over the drinking water quality report, this will hopefully give you some context on the units that are used to measure all of these contaminants. So a part per million is equivalent to a milligram per liter, and it's also a drop in a hot tub. So very small. But then we have parts per billion, which is even smaller, a microgram per liter, or 1 drop in an Olympic-sized pool. And then we have parts per trillion, even smaller, a nanogram per liter, or 1 drop in a 6-acre lake. And I want to comment that contaminants have different health effects at different levels. So for example, 1 ppm, a part per million, 1 part per million of a contaminant may be safer than 1 part per billion of another. So it's very dependent on the type of contaminant we're talking about. It's gonna vary. So now I'm gonna dive into some specific contaminants that I know are of interest. So lead and copper, these are naturally occurring toxic metals, and they can enter the drinking water when plumbing materials that contain lead or copper corrode. And that just means that like water goes through, and if there's corrosion, the water is reacting with the piping materials, and then lead and copper are entering your water. And lead can be harmful to human health, even at low exposure levels, which is why the maximum contaminant level goal is set to 0. So there's a lot going on around lead and copper regulations, and this is just to provide a brief summary of what has happened and what continues to happen around them. In 1986, that's when the Congress amended the Safe Drinking Water Act, and they prohibited the use of pipes and fixtures that were not lead-free. And they defined lead-free then. And then, as time went by, in 1991, they published the lead and copper rule. And this lead and copper rule continues being updated as there's more research, and also to further protect you from lead and copper exposure through drinking water. So there's been a ton of revisions throughout the years, and the definition of lead-free has become stricter even. And in January 2021, the EPA issued the lead and copper rule revisions, which was the first set of major revisions. And recently, in 2021, they committed to propose the lead and copper rule improvements by October 2024. And I'm mentioning this because as part of these improvements, the water systems are required to create lead service line inventories by October 16, 2024. So if you click, so just to going back to like this diagram that Atli showed when she was talking about the path to tap. So the thicker line that says water main, that's part of the distribution system. And then the service line is the thinner line that directs your water towards your home. And so this new set of improvements is asking water systems to create an inventory of all of those service lines that are lead, and they will have to replace them. Again, this is part of the new set of improvements to further protect you from lead and copper. You go back. And you can click again. Yeah, you can go to the next slide. Okay, so now I'll move on to PFAS. So PFAS are per and polyfluoroalkyl substances. And thank God the acronym PFAS exists, because that's a very complicated set of terms. But this is a group of more than 12,000 human-made substances. They are resistant to heat, water, and oil, which makes it really hard for water systems to break them down. And that's why they are called forever chemicals. And they're, like I said, human-made, so they're not naturally occurring substances. And some common ones that you might have heard are PFOA and PFOS. These are 2 types of PFAS. And the way they enter, sorry, if you can go back. Yeah, just they are used in a lot of like common consumable products, and that's why they have like an easy access to soil, the ground, and other things as well, because they can be found in like shampoo, for example, pesticides, etc. We go to the next slide. And then just to clarify a little bit about the term, because it's a little confusing. Again, PFAS stands for per polyfluoroalkyl substances. So it's easy to think that the S is like to make it plural, but this is like the main term. So PFAS is like the parent term. And then if you click again, like I mentioned, more than 12,000 ones, PFAS. And this is just to show 6 of them, which I will refer to back later. They are here for a reason. But yeah, just to exemplify what PFAS are. If you go to the next slide. So similar to lead and copper, there's a lot going around PFAS. They started being used in the 1950s, but they weren't like tested for till the early 2000s. And that's why they are in so many products. But then after they started being tested for, a lot of research started alongside, and then the EPA started different bans. And for example, in 2019, more than 180 countries banned the production of PFOA, which is one type of PFAS. And since then, a lot of regulations have become established. So in 2020, for example, California State Board established notification and response levels for 4 PFAS. And the most recent update is actually March of this year. The EPA announced proposed national primary drinking water maximum contaminant levels, so national regulations for 6 PFAS, which are the ones that were in the previous slide. So if you go back, these are the 6 PFAS that the EPA has proposed regulations for. They are not established yet, but they're proposed. So research is moving forward, the regulation process is also moving forward. If you go to the next slide. So going back to disinfection byproducts, these are chemicals, like I mentioned before, that are formed when disinfectants like chlorine are added to the water and react with organics or inorganics that are present in the water. So to explain this in more simple terms, the disinfectant, like I mentioned, is used. It's usually the last step of treatment and is used to remove microorganisms. But because disinfectants like chlorine are chemicals, naturally, they tend to go through chemical reactions. So it's the last point or the last step in the water treatment process, because that way the water is clean enough so that when you add this disinfectant, there will be nothing for it to react with. But if there's material present, then disinfection byproducts may form. And 2 of the most common types are trihalomethanes and haloacetic acids. And I mentioned those because those are terms that you might see in your water quality report, because they're usually tested for. But yeah, and then water agencies are responsible to making sure that the water is clean enough before adding the disinfectant, again, to avoid the formation of disinfection byproducts. And now a little bit about perchlorate. So perchlorate is an inorganic chemical used in solid rocket propellant, fireworks, explosives, and a variety of industries. It is both naturally occurring and man-made, and it gets into drinking water through contamination from historic industrial operations that use stored or disposed of perchlorate. And in 2022, the EPA completed a review of draft regulation for perchlorate, but then decided not to regulate perchlorate in drinking water. However, in California, there is a primary maximum contaminant level for perchlorate, so it is regulated in the state. So that was a little bit about some various contaminants, and there's a water quality characteristic, so not a contaminant, that I know is of interest. It was flagged as the #1 issue in the needs assessment. And so I want to talk a little bit about water hardness. So water hardness is the amount of dissolved minerals in the water, specifically calcium and magnesium. And it's naturally occurring in groundwater. And like I said, it is an aesthetic issue. It is not dangerous, but it can cause mineral buildup in fixtures. So when hard water goes through the pipes and the pipes are heated, for example, these minerals tend to precipitate, so they become solid and they can build up in fixtures. So that's one of the things that everyone should be aware in regards to water hardness. However, another thing that you should be aware of is that we need minerals. So hard water can also actually be a big contributor of calcium and magnesium as part of our diets, because we need that as humans too. So I talked a lot about contaminants, and now let's talk a little bit about what you can do about them. So first, in relation to health-related contaminants, lead and copper. Like I mentioned, these are toxic metals related to premise plumbing specifically, and service lines too. But talking about premise plumbing, like Adley mentioned before, these are the pipes physically inside your building. And so you can do something about it. And these are some of the actions that you can take in order to protect your home from lead and copper. And so one of the things that you can do is test for contaminants at your tap. This is a way to just get data and see if there is lead and copper contamination in your water. Another thing you can do is hire a local plumber to inspect the pipes and perform a visual assessment. So not all the, like I mentioned also in the timeline, lead-free pipes, not lead-free pipes are prohibited. So pipes need to be lead-free. But there are still some pipes that are not lead-free, which is why the EPA is now requiring the inventory and for water providers to replace lead service lines. So that's super important. There's a lot of work going on around that. But if you hire a local plumber to visually inspect, they can usually tell, it's very easy to tell when pipes are corroding. So if they're corroding, that just means you might require maintenance, and scheduling pipe maintenance every couple of years is also a good way to ensure that your pipes are in a good state to avoid corrosion. And then in relation to the aesthetic issues, again, water hardness is not dangerous, but it's a consideration, and it's your choice if you want to soften your water. And there are ways for you to do that. So you can get water softening equipment to install at your home. And there are different kinds of water softeners. And just to explain how they work. So essentially, if you see this diagram, hard water will go through it. And the water softeners have resin, which is like a specific material that it will work like a magnet kind of. So the hard water will go through, and the minerals in the hard water, so like calcium and magnesium, will stick to the resin. And then the water will go out without those minerals. So then it's soft water. And like I said, there are different kinds. I do want to note that automatic water softeners are not allowed in the Santa Clarita Valley, and that is to protect the Santa Clara River. The reason is because since after all the minerals get stuck to this resin, salty waste is created. And the automatic water softeners discharge it automatically. And the problem with that is that it ends up going into the sewer and not treated for, and then it would end up in the Santa Clara River. So that's why we don't want that. That's why they're prohibited here. But there are other kinds. So one that is recommended is the exchange tank softener. So instead of being automatic, you have to exchange the tank. And so once that salty waste is created, you take the tank away and you send it to a place that's permitted to clean and discharge that salty waste in a safely manner. And yeah, then you just replace it and it keeps working the same way. And then another thing that you can use is the salt-free water conditioners. So these are not exactly softeners, so they will not soften your water, but what they will do is that they will prevent the minerals to accumulate in your pipes. So they will prevent that buildup that I was referring to earlier. And now I will pause for questions. I know this was a lot. If you want to go back to any of the slides, let me know. Yeah.
I did see one question in the chat about how do I test my tap water?
Yeah, so there are lots of resources online, and I can follow up with some of those links directing you to them specifically. But essentially you can order a kit online. There's a company called at least in the link in the chat. It's called Simple Lab, and you're able to order a panel online. They will send you a kit with specific instructions and videos for you to follow when taking the sample, and then you send it to them, and then they will give you the results and explanations about what's found. It's very important that if you do want to test your water, that you're really careful when following those instructions, because contamination from other sources as you take the sample can happen pretty easily. So that's just something to keep in mind. So if like there's a huge like contaminant concentration that shows up if you test your water and you get the results, it's important to understand first like the type of contaminant for which that occurred, and think, okay, does it make sense, or was it like, oh, I accidentally like spilled this in my sample and then it showed up as high. And a good way to do that is to compare it with the drinking water quality report, which I will go through next, because it's a good measure of comparison to see like, oh, okay, these levels make sense, or, a point of comparison, because it's still representative of your water system. So you can compare those numbers. Does that
Andrea,
make
I'll
sense?
just add on that there's a local lab, fruit growers lab, that some residents use to test their taps.
I also see a question in the chat about the copper. I'm surprised about copper. What is the danger? It doesn't corrode or rust and it's supposed to be naturally antibacterial.
So copper is similar to lead in that it's a toxic metal, and so it does corrode, and that's why they group them as part of the lead and copper rule, because those regulations go hand in hand. There's a lot of talk about lead because it is more common to find lead fixtures and for it to corrode more easily than copper, but both are toxic chemicals, metals, sorry.
Any other questions before we move on to the next section? And Natalie also put the link to the local fruit growers lab to another place to do tap testing or to test your tap water.
Sorry if I missed it, but did we address the question from Hamas?
Oh, I don't think so. Let's see. Okay, so this is very informative. Another pollutant I've been looking into is triclosan. It's found in common home items, toothpaste and soap. It seems to be common in waterways now and affecting water, life, and humans, still being studied.
Yeah, I haven't done much research about it myself, but it is important that you bring it up, because it's to show that there is a lot of research going on about many different contaminants, and it going back to like the timeline of, or the pathway to create regulations, that research is the first step. And so all of these things are being studied. And again, if evidence is found that it's affecting human health, then that'll trigger the process of creating regulations. Okay, so now I'll talk about the drinking water quality report. So first, in general, like Amanda mentioned in the beginning, the annual water quality report is also known as the Consumer Confidence Report, and all public water systems are required to provide this to their customers. And it's released every year by July 1st, and it provides information including the water source. So many of the things that I talked about, actually, where your water comes from, a list of all the regulated contaminants and potential health effects, and then the contaminant level. So water providers are required to sample their water, and this is where they report all those values in. And again, released every year by July 1st, so the newer one is coming up. But like I mentioned before, the Santa Clarita Valley Water Agency has already released their most recent one. And just one thing that I also want to point out, on March of this year, actually, this is recent, the EPA announced upcoming changes to the Consumer Confidence Report regulations, because there are also regulations about these reports. And the goal is to make them more clear, more accessible, and just easier to comprehend. They mentioned something about translation services, which I think is great. And another big change is that water providers who serve more than 10,000 people, they will be required to provide this report twice a year instead of once. These changes are not in effect yet, but it's a work in progress. So now the water quality data table specifically. When you see your report, it might be overwhelming. The water quality data table has a lot of information, and so I want to try and simplify it a bit. I do want to note that the table in your report might not look exactly the same as this one, but they will show the same information just in different ways potentially. And to simplify it even further, I want to focus on two columns specifically. So the water quality data table will list all the contaminants. They might categorize them in the categories that I was referring to earlier or not, but they will be there. And then the MCL column, the maximum contaminant level, that's the one that will show the regulation, the limit. And then the other one, the other circle, the range or average, that's the one that's gonna show what's been measured. And so these two columns are very helpful because those are the two columns that you want to compare. So you want to check if the range or average, what's been measured, is less than the limit, the maximum contaminant level. If it is less, then you know that your system is complying with that regulation. And just to go over some of the letters that are shown here, the DLR, you might see that a lot. It's the level for reporting purposes. So here when it says less than DLR, what it means is that what was measured was so minimal that it's not worth reporting. It's either, well, it was either too little for it to actually be measured, to have an actual number, or too little to be worth putting in the table. So for example, here we have aluminum, the maximum contaminant level, we have the units, and then we have 1,000, and the range or average says less than DLR to 0.1. So we know that what was detected was less than what can be measured or has to be reported, up to 0.1, which is still a lot less than 1,000. So with that, you know, okay, there's no violation. And water providers are also required to physically tell you whether or not there's been a violation. So some tables will have a nice column like this one saying yes or no, is there a violation? Others will be more subtle and will tell you before the table that if there's a violation, they will mark it with an asterisk, or others will have a different section that lists the violations, if any. So there's a way for you to know. There are many ways for you to get an understanding of that. So if you go to the next slide. Okay, so now we'll go through the exercise of finding your water provider, finding the report, and reading and understanding your report. So the links will be sent or have been sent in the chat, and I will take over the screen to go over the steps. Okay, so I have all the windows open, but we will start from the beginning. So if you go to the first link, can you see my screen? Yeah. Okay, so if you go to the first link, that'll take you to this map. It's another one of these tools that I find super helpful. And this will help you find who your water provider is. So if you know who your water provider is, you can follow this step as well. You don't have to. You can, but if you want, you can type in your address here, essentially. I am going to use the address for the Santa Clarita Valley Water Agency. Sorry, I'm gonna copy it because I don't know it by heart, but you can just type in your address. So if you type in your address, it will start showing up here, and then you can just select it and hit enter, and then a point will show up on the map, and you can confirm that that's your address. And so then you can hit the adjacent pink area. So I'll click there, and it gives me my water provider. So if you zoom out, then you can see your water system's boundaries, which is pretty cool. So this is the Santa Clarita Valley Water Agency, Santa Clarita Division. And so this is my point. And I know then that that's my water provider. And so first step, check. So this is my water provider, and I'll copy that name. So going back to this slide. So, okay, I found who my water provider is. Now let's go to step number 2. So if you go to that link, it'll take you here, and you can just type in your water provider's name. So I copied it, and now I pasted it, and it should take me to this page. If that doesn't work for you though, there's this system, this website is very like case sensitive. So sometimes it works, sometimes it doesn't. If you copy and paste it exactly as it was in the map, it should work. But in the case that it doesn't, you can type in keywords. So Santa Clarita, and I hit search for systems. So now it gives me options. But I know from this map that it was the Santa Clarita division. So it's the first one. And so I click the system, and it takes me back to the same page. And then there's a lot of other information here. Feel free to explore that later as well. Right now, I want to find the consumer confidence report. So I go to this column and hover over this, and it'll give me the years, because many of the reports will show here. And I want the most recent one, but like I mentioned, we are in a weird period because they are almost due, but not quite. So many water providers won't have them here yet. So if I go to 2022, for example, I actually won't find it for the Santa Clarita Valley Water Agency, not in this website, but I know it's been released. So I'll get to that later. We will review the newest one. But in this particular case, because it's before July, you will go to the previous year, and you will find it linked here. And so then you can just click it, and that'll take you directly to your consumer confidence report. So yeah, this is the previous year, this last year's Santa Clarita Valley Water Agency's report. Like I said, I know that the newest one has been released. It's on their website. So that's the one I'll go over for step 3. So step 2, check, I found it. Okay. So then step 3, this is the newest one. I think, let me click this to make sure. Okay, so it's a very nice report. It has a lot of helpful information. It defines many of the things that I talked about today. It talks about the water sources first, and then it gives some other information about their treatment facilities, the different types of contaminants. They talk about lead and copper, microbiological, which is something I talked about, organic compounds, something I talked about, and perchlorate, PFAS, lots of helpful information. They define the terms here. Again, I defined some of them, like the maximum contaminant level. And then we get to the table. So as you can see, it looks more complex than the one that I showed in my slides. And the reason, at first sight though, because the reason is the Santa Clarita Valley Water Agency has lots of divisions. So that's why there are many different columns. So there's the import division, there's a treatment plan for which they have information, the Santa Clarita Water Division, Valencia Water, etc. So it looks more complex than it actually is. I'll zoom in just to go over the exercise, but essentially we have the same columns that I was referring to earlier, the MCL or the maximum contaminant level and the actual regulations, and the range and average. So when you read this, you can go through the same exercise and compare. So we have aluminum, its maximum contaminant level. Also, just to note, I know that in my table it said 1,000, not 1. And the reason is because I use different units. It's the same thing, but I just use different units. And then, so, okay, maximum contaminant level. And then we have the minimum, maximum, and average. So here, as you can see, it's less than DLR for all of them, which again means it's too little to even put it in the table. So you know it's all good. And then you can go through, and this one's so nice because it categorizes them in the same categories that I was telling you about. And they include some others. They include secondary standards, like I said, regulated here in California. And yeah, lots of helpful information, comparing back and forth. Yeah, and if you have curiosity about anyone specifically, you can always look up more information, and they have a lot of information explained in the report itself. So it's very helpful, and it can take you some time to read it all, but I think it has lots of helpful information. And then, yeah, that's pretty much it for the drinking water quality report. Like I said, recently released, and if you have a different water system, you can wait till July. Feel free to read the previous one too. It's super useful, again, just to get an understanding of your water quality. But yeah, the newer one will be coming soon.
All right, thank you so much for that, Andrea. And let's see, does anyone have any questions before I jump into these upcoming events that I'm going to share with you?
I have a question
Yeah.
about like new refrigerators that have filtrations in them. Are those generally good? Is because that's where I get my drinking water now. I used to, go to Big Bear actually and bottle it because the water tasted so good up there. But I'm just curious.
Yeah, so the filters vary in type, but I think most of them will be just like carbon based, and they do treat mostly aesthetic issues, which is why I know my roommates, for example, they prefer filtering the water like extra because they like the way it tastes. I personally don't mind, so I'm okay drinking tap water. But yeah, it ends up being a personal preference.
Okay. Thank you.
And it looks like Lynn has her hand up.
Yeah, I was just kind of surprised that they had the different areas of water agency listed. Like, I'm in Newhall County. That used to be our water district. And so I thought that everybody, because I missed the nice tour that was given, I don't really know, but I mean, I thought it was all mixed together, but the Newhall County is still a like separate water source for the Santa Clarita Valley. I don't quite know. How does that work?
Yeah, so it's the same agency, and they have different treatment plans because they provide water to so many people. They do, for capacity purposes, they do have different treatment plans, but it's the same agency that regulates it all. And actually, I was reading recently on their website, they are trying to make it more simple. They are trying to be able to combine all of those divisions. By law, they are required to separate them like that in the report, but it's the same agency. But they do recognize that it makes it more complex. which is why they are pushing to not needing to do that anymore.
So the water for Newhall district is coming from a different treatment plant than the other divisions are. Is that right?
Not necessarily, but let me share my screen again. So if you go to the Drinking Water Watch website, they have like a different tab for each, so you can learn more about. There's also lots of helpful information in the Santa Clarita Water Agency in their website as well. But if you hit Newhall, for example, it gives you like the address there, and you can learn a little bit about like that division specifically. But it's, like I said, it's the same agency, and it might be treated in a different water treatment than some of the other divisions. I don't know by memory which ones treated where exactly, but the agency does have that information on their website.
Thank you.
Any other questions from anybody? Maybe we can put up the event slide, and if anybody has any questions while that's coming up. All right, well, I want to invite everyone to this Saturday. We have a tour of our restoration sites up in San Francisco Canyon. The Tree People has been working on for some time, and we're going to have a tour of those sites and make the connection between watershed health, climate change, and open space restoration. So that will be really awesome. Please come out on Saturday. It should be a lot of fun. And then we are going to have a follow-up to that session. And we do have a date now, June 22nd, just was determined a little earlier today, where we will have an online session like we did today, talking about the various elements of fire ecology, climate change, open space restoration, and how that impacts our water supply and water quality, all those elements. So I hope that you can join us for some more of these water talks, tours, and workshops. Thank you so much for joining us today. And again, feel free to put any questions in the chat. Oh, and yes, and now we have our final exit survey. Any remaining questions here? Let's see, here it is, the survey. So in the chat, there is that link there that will kind of work you through some of the learning objectives that we identified in the beginning and see how you can respond to these.
Just to share, the exit survey is really also to help us gauge if we should do another workshop or share more materials. So it'll be super helpful to get information from you all so it can guide what we're creating and create more helpful materials for you.
Yes. So thank you all for taking the time to join us tonight. Much appreciated.
Thank you. It was really interesting and informative. You guys really know a lot. Bye-bye.
Thank you
Bye.
so
Thank you
much
for
for joining
joining.
us.
Thank you so much, everybody. Gabriela. Team, if we could just stay on for 1 minute, that would be great. Now we all have nights to get to. You can stop sharing now, I think. Recording.